All right, so to find area of parallelogram, first off on your notes, draw a parallelogram. Do your best, draw a parallelogram. So remember, parallelogram, opposite sides parallel, opposite sides congruent. Should look something like mine up here. I cheated. Yep. Okay, it says begin by showing the height. Now the height of the parallelogram is also known as the altitude, and that's a line straight from this corner perpendicular to the base, okay, which by the way we call this the base. Okay. And so I'm going to go ahead and draw the height twice. Notice this is the height, these arrows. Okay. So for an explanation on why this formula works the way it does, I'm going to kind of show you here. So first off, I'm going to label my points here. I'm going to call A, this point where the height lands is B, this corner over here is C, D, E, and then F. Okay. So for a quick explanation on why this formula is going to work the way it does, it says think of removing triangle CED. So that's this guy over here, right? And moving it to the left side. Okay. So think about what would happen if we did that. So if I take triangle CED, right, and I move it over here to the left, so it's no longer there, notice what we have. We get a rectangle. Okay. So I'm going to call these new points, this translation, D prime, E prime, and C prime. And then notice the remainder of my parallelogram stays put. And so we've got A, C, E. Okay. And so notice we get a rectangle, A, C, E, E prime. And what's the area formula for a rectangle? Length times width. We went over this yesterday. So length times width for a rectangle. But notice how this relates. The width of this rectangle is the same as the base of this parallelogram. The length of this rectangle is the same as the height of this parallelogram. And so the area for a parallelogram is simply the product of the base and the height. It's base times height. Okay. So again, the base of the parallelogram, and then we have the height of the parallelogram. Now notice the height is not this diagonal. It's straight up and down. That's important. Okay. Now to find the perimeter of a parallelogram, it's basically the exact same as for a rectangle because we have opposite sides parallel. And so if we have 2 times one side, 2 of these, and then 2 of these, right, just add those together. So it's the same idea. Or we can just add up all 4 sides. Okay, so look at example 1. It says identify the base and the height of the parallelogram, then use them to find the area and the perimeter. Okay, so what is the base of this parallelogram? Yeah, so base is that side 12. Right, so notice we have 2 bases. Really. Right, so the base is 12. And then the height of the parallelogram would be this dashed line, or 5. So base of 12, height of 5. We also want to find the area. The area is base times height. So we have 12 times 5. So the area is 60. The perimeter, well, there's 2 bases, right? So we have 2 12s. And then the other sides, and this is where you just want to think about it for a second. We're talking about these sides are the outside. So those are both 8. Right, they're the same. So we have plus 2 times 8. So 24 and 16 make 40. Come sit right here. You won't hear you.
No, I prefer like the daddy's hearing you over there.
I need some coffee.
George is not for water.
All of hourglass.
It's bothering his sleep.
Okay. Next example, identify base and height of the parallelogram, then use to find the area and the perimeter. So what is the base of this parallelogram?
6.
The base is 13,
The height is 6.
and the height is this vertical distance, so it's 6. So the area is base times height. 13 times 6 is 78. The perimeter,
13 times 2
we've got two 13s,
and 8.
and then this is where you got to just pay extra close attention. These are both 8, so we have two 6s. So 26 plus
You have
12.
2 6s or
Two 8s, thank you. Sorry, two 8s. I said something and wrote something else. So 2 times 8, we have 16. So 26 and 16 gives a perimeter of 42.
Alexander. Do you have a pencil? Do you have a pencil? Yeah. Huh? Nothing? Yes.
Here, Matthew, slide it out.
You have some sprays and sharpie?
She doesn't have any more.
Okay, next example. So on these first two problems, we were given the base and the height. Right? I mean, they're fairly straightforward, given the base and the height and all the sides. So what happens if we're not given something? So look at example 3. It says identify the base and the height of the parallelogram, then use them to find the area. What is the perimeter? So what is the base of this parallelogram?
18.
Okay. What about the height?
Don't know it.
Okay, so height we don't know. So we defined it. So let's call the height, we'll use Matthew's suggestion, x. Now we have an angle here. We have 60 degrees. Yesterday we talked about special right triangles, 30, 60, 90. And that'll work for any 30, 60, 90. We could jump to a pretty easy conclusion right here. If this is 12, how long is this short leg? It would be 6. And then this would be 6 squared root of 3. We could do that fairly easily. But what if it weren't a special right triangle, which on the homework or on the assignment, there are a couple where there's not special right triangles, so you need to know how to do it. So what else do we have dealing with angles? Yeah, so something, right? We have SOHCAHTOA. So we're looking for x, which is the opposite. We know the hypotenuse, so we're going to use sine. So sine of 60 equals x over 12. Cross multiply, so x equals 12 times the sine of 60. And we can put that in the calculator, and we find out that x is equal to 10.392. Now, by the way, what is 6 times the square root of 3?
10.39.
Exact same thing, right? So it's 10.392. So either way, we get the same value. Okay? If it's a special right triangle, notice how much faster this was than this. If it's not a special right triangle, you really don't have any other alternative.
So the height is 10.
So the height is 10.392.
We can find the
So now we can find, what do we need the base and the height for? Area. We need the base and the height for the area. So the area equals 18 times 10.392. Which again, use calculator, 187 point something.
187.05.
Okay. So there's our area. Now do we need both the base and the height for the perimeter? No, which one do we need? Okay, we need the base and then the slanted one. It doesn't really have a name, just the other side. So we have two 18s and two 12s.
60.
So 36 and 24 make 60. So if you see angles given, you need to figure out which side or sides you need to find. Did we really need to know this length was 6?
No.
In this case? No, not really, right? So that's kind of extra. We did need the height here. So you got to look and see, okay, what do I really need to figure out my area and my perimeter? And then finally, if the area of a parallelogram is 96 square inches and the base is 20 inches, what is its height? Now, before we start, I want to point out this is a unit. It's inches squared. If this is an inch, then a square inch is that. Okay, so it's saying that if we draw a parallelogram and we calculate its area, we can fit 96 of these guys into that. That's all this is saying. So we're not squaring 96. Let me be very clear. There's no 96 squared here. Okay. But we do know the base is 20. We want to know what's the height. I'll call it h. Okay. Now remember, the area of a parallelogram is found as area equals base times height. I'll just use b and h because it's immediate. We know the area is 96. The base we're told is 20. And the height. So how the heck do we get height? Okay, so we divide 96 by 20. Why did we divide by 20?
Because that's what the base is. So you take the height. No.
Why do we divide by 20?
Because 96 is in the 20 is in the physical one. Divide 20 by 96 is
Okay, but why by 20?
I don't know, I didn't understand.
Oh, no, wait,
Why are we dividing by 20?
height is 4.8.
Get rid of the 20 next to me.
How does it get rid of the 20 though?
Canceling it.
What is, yeah, but what is 20 divided by 20?
0, 2.
1.
1. So 20 times height divided by 20 leaves us with 1 of heights, which is what we're looking for. We're looking for what is 1 of the heights. Right? So if we took 20 of the heights next to each other, we would get 96, right? We just want to know what's 1 of the heights. So we get 4.8 inches. So our height, I guess I'll write it over here, height equals 4.8 inches. Height. So there are 11 problems today, not a whole lot. The first few are just like our first 3 examples. So when you get stuck, look back at, for the first couple, look at example 1 and 2. Then when you get to the trig stuff, look back at example 3. Then you'll need to look at example 4. And then you'll have to use your reasoning to figure out some areas and things like that, more challenging. So the first 7 or so problems are fairly straightforward problems. The last couple are a little bit more challenging. You have to use a little bit more problem solving, but not too big of a leap. Okay. Any questions on examples 1 through 4 at this point? Yeah. Yeah. Any questions on the examples though before problems? You unclear?